So we have discussed about the rectangular components of a vector. So here we'll discuss how to apply that concept to find the resultant vector of the resultant or the equivalent of multiple vectors which are present. So here in this question we have been asked to find out the resultant of the following forces which are acting. So here we have a 40 Newton force vector, a 50 Newton and a 60 Newton force vectors. 40 Newton is at an angle of 60 degree with respect to the x-axis, and 60 Newton is at an angle of 30 degree. This is in the first quadrant, this is in the second quadrant, in this way. So we have to find out the resultant using the component of using the concept of vector components, splitting it into vector components. So here we have to find out for this let's say resultant R, the final resultant R, we have to find out the x component and the y component. So first the x component. So here the first component which is directed along the x-axis directly, that is 50 Newton. Okay, first that. Then we have this 40 Newton force. So we have to find out its x component. Okay, its x component, which is equal to 40 cos 60 degree. Okay, this 40 cos 60 degree, this much Newton. And then we have to find out the x component of this 60 Newton force along the x-axis, and that is equal to 60 cos 30 degree. This 60 cos 30 degree, 60 cos 30 degree. So that is the component of the vector along the x-axis. So it is equal to, this is cos 60 degree, 40 by 2, that is 20, and this is 60 cos 30 degree, that is 51 plus 9. So that is equal to 121.9, 121.9 Newton. That is the x component. So we have got the x component. Now we have to find out the y component. Okay, so for the y component here, this 50 Newton force has nothing in the y direction. It is totally along the x-axis. So there is no component of this force along the y-axis in any direction. So that will be totally 0 Newton for 50 Newton. Then for this 40 Newton force, for this 40 Newton force, the component along the y-axis, that is equal to 40 sine 60 degree, this component along the y-axis acting upwards. So that is equal to 40 sine 60 degree, that much Newton. And then we have this 60 Newton force. Okay, this 60 Newton force, and we have to find out its y component. Okay, so its y component will be like this, downwards, acting downwards. This is 30 degree. So that is equal to 60 sine 30 degree. Because this force is acting downwards and it will have its x component acting towards the right side, but its y component will be acting downwards, and that's why it will have negative sign, which is equal to 60 sine 30 degree. Okay, so that is equal to 0 plus this will be around it is coming around 34.6, and this is 30. 6 sine 30 degrees 1 by 2, that is equal to 30 Newton. So it is coming around 4.6 Newton. That is the y component. So we have got the x component, we have got the y component. Now again, see, the y component is coming positive, so it means that the y component will be acting upwards. The x component is coming positive, so it means it will be acting along the positive direction towards the right, like this. Okay, this is Rx, this is Ry. So now we will evaluate the resultant. So the resultant vector will be like this. Okay, we have Rx equal to 121.9 Newton, and we have Ry equal to 4.6 Newton. Okay, so this will be the resultant R vector. So that will be equal to the magnitude of R, the magnitude will simply be Rx square plus Ry square root over, okay, which is equal to 121.9 square plus 4.6 square root over, which is equal to coming around 121.986. Okay, let's round it off to 122 Newton. That is the magnitude, and the direction, that is equal to this with respect to the x-axis. That will be equal to tan inverse of Ry by Rx, which is equal to tan inverse of 4.6 by 121.9, that is equal to so that is equal to it is coming around 2.2 degrees. Okay, 2.2 degrees, that. Okay, so this is the magnitude and direction of the resultant. So here we use the vector components approach, and that simplified the whole operation. So first we took the individual vectors, we found out their x and y components, then we added the x components together, we added the y components together, and then using the rectangular component approach we found out the resultant. So this approach always simplifies the whole thing. Okay, simplifies the whole operation. So this is the this is an example which I thought we should discuss so that we understand this whole operation of vector components, vector operation using rectangular components approach. Okay.